Welcome to lecture number 45 of fuzzy sets, logic and systems and applications. Here in this lecture we will discuss some examples on composite linguistic terms. Now let us take an example here where we have to find a composite linguistic term for slightly light. So, for light linguistic term we have a fuzzy set here, which you can see is for light, which is represented by a continuous membership function mu light, by bell shaped membership function here, and now since we are interested in slightly light, so slightly, so I will write here for slightly we need to dilate the fuzzy set. So, this way when we dilate the fuzzy set, we get a new fuzzy set, which is here is this slightly, for slightly the value of k, because we are dilating. So, the value of k here I am writing k is equal to 0.5 for slightly. Similarly, if we have more or less, this is same as slightly. So, either we say slightly or we say more or less, we need to dilate the fuzzy set. So, here in our case, if we say light and then we say slightly light, so then for slightly light we have to dilate the original fuzzy set light to get slightly light, which is mentioned here, which is the composite fuzzy set for slightly light is shown here by the red color. Now, in case we are interested in extremely light. So, for extremely light the value of k becomes 8. So, the value of k for extremely, this for extremely, and this extremely is same as which is same as very, 3 times very. So, we have already have the fuzzy set for light, which is here, we have fuzzy set for light, and then if we are interested in extremely light, it means we have to concentrate the light fuzzy set 3 times. So, this we have this fuzzy set, which is represented by blue color, is for light fuzzy set, and here you see the red fuzzy set, the red color fuzzy set is for extremely light, and here this extremely light is basically we have got by taking k is equal to 8, means we have this has been concentrated means the fuzzy set has been concentrated. So, this way the composite fuzzy sets can be obtained. Here this is called the hedge. Extremely light means we are obtaining the linguistic hedge, and thereby we are finding the resulting fuzzy set. So, we see that this red color fuzzy set is for the extremely light fuzzy set, and this we have found as the concentration of light. So, extremely light we have got out of concentrating the fuzzy set thrice. Now, let us take another example, another composite fuzzy set where we need to find the heavy but not too heavy. So, we have the fuzzy set here, fuzzy set representation for the linguistic term heavy, and here also the mu of heavy is nothing but bell shaped membership function, and the heavy fuzzy set, and I mean the fuzzy set for heavy linguistic term is shown here. And then let us first find the fuzzy set for too heavy and then not too heavy, and then let us connect heavy and not too heavy together to get the composite fuzzy set. So, this fuzzy set is for heavy, then this fuzzy set is for too heavy, this is for too heavy, this is for too heavy. Too heavy, you know how did we get? We simply concentrated this and we have got the fuzzy set for too heavy. Now, let us quickly find the not too heavy. So, the fuzzy set for heavy is here, too heavy is here, and not too heavy is here, not too heavy. Now, since we have heavy and not too heavy fuzzy sets, let us now use the connective but in between and get the modified fuzzy set for heavy but not too heavy. So, when we do this, we see that since we have heavy here and then we have too heavy here, we have not too heavy here. So, now for finding heavy but not too heavy, we have to use the connective but, and we have to use and for but, means we are taking the intersection. So, we will take the intersection of these two. So, here this is not too heavy, this is not too heavy, and this fuzzy set is for this fuzzy set is for. So, means we have two fuzzy sets, one is for heavy and other one is for not too heavy, and when we superimpose both the fuzzy sets on each other and when we take the intersection of this, we are getting the resultant as heavy but not too heavy. So, let us now look at this. So, this portion is giving us the intersection here of heavy but heavy and not too heavy. Intersection of heavy and not too heavy. And we already know that this is for heavy, this fuzzy set is for heavy, this for too heavy, and this for not too heavy. So, this way we have found this outcome after taking the intersection of the heavy and not too heavy, and this is what is the fuzzy representation of the linguistic term heavy but not heavy. And we already know that this is for heavy, this fuzzy set is for too heavy, and this fuzzy set is for not too heavy. So, this way we have seen that we have found the new composite fuzzy set, which is the outcome of heavy but not too heavy. Let us quickly go ahead and find the fuzzy set for slightly heavy. Here this slightly is a hedge, and for slightly, for getting the slightly heavy from heavy, we need to dilate. So, for slightly K is going to be equal to 0.5. So, for slightly heavy, what we have to do is we need to dilate the primary fuzzy set, that is the heavy fuzzy set, the fuzzy set for heavy. So, we have here the fuzzy set for heavy, and this red color fuzzy set is the fuzzy set which is represented by red color is basically for the slightly heavy here. So, how did we get this slightly heavy is just dilating the heavy fuzzy set. So, this is very simple. So, when we have any primary fuzzy set and we are interested in the slightly of this fuzzy set, this primary fuzzy set, we dilate. So, this is going to give us the fuzzy set like this. So, dilation is going to give us the slightly heavy. So, dilation of heavy is going to give us the slightly heavy. Now, this way on the same lines we can find extremely heavy. So, for extremely, as I have already mentioned, this extremely word, this extremely we can get by concentrating the primary term thrice. So, the extremely can be obtained like extremely heavy can be simply the concentration and then concentration and then concentration of heavy. So, this means that 3 times concentration of heavy, and this is a normal concentration. It means the final value of K is going to be 8. So, in this case when we are finding the fuzzy set for extremely heavy. So, extremely heavy basically is the concentration with K is equal to 8, and when we do that we are going to get this fuzzy set which is represented by a red color, and this is the original, the primary term for heavy. This is how we can find the composite linguistic terms, the fuzzy sets for composite linguistic terms. Now, here the same can be represented on the represented together. So, we see that when we have a bell shaped membership function for light linguistic value and a bell shaped membership function for heavy linguistic value, but here the parameters of this bell shaped function membership function are different for light and heavy. You can see here in case of light we have 2350 and in case of heavy we have 23130. So, this membership, this fuzzy set is for heavy, this for heavy, and this fuzzy set is for light. So, when we have these two primary terms, and now you can see when we obtain the linguistic hedges and thereby the composite linguistic terms and the representation as fuzzy sets, we see that here when we had light fuzzy set, this blue color is for light, I can just tick here. So, you can see blue colored fuzzy set is for light, and then here we have green colored fuzzy set for heavy, and when we are interested in slightly heavy which we have obtained by dilating heavy. So, this we have obtained by dilating heavy, means we have simply taken K is equal to 0.5. So, this you can see here, this is the dilation of heavy, and you see the extremely heavy here which is here. So, extremely heavy which we can simply concentrate thrice the heavy membership heavy fuzzy set, and so we basically concentrate here thrice for getting the extremely heavy. This is extremely heavy, and similarly when we are interested in heavy but not too heavy. So, we use the connective but, and this we are getting by simply getting the intersection of heavy and not too heavy, and then when we are interested in slightly light, we take the value of K is equal to 0.5 as I mentioned, is here we dilate, and similarly for extremely light we are taking the concentration 3 times, means K is equal to 8. Similarly, here we use light but not too light. Similarly, we have light and then we take the intersection of light with not too light, means we get first the complement of too light which becomes not too light, and then we take the intersection of this with light. Similarly, not light and not heavy, we take the complement of light and not we take the complement of light and heavy, and then we take the intersection of these two to get the composite terms. So, this way we see that when we have primary terms, primary fuzzy sets, then we can obtain suitable composite linguistic terms, and thereby its representations as fuzzy sets very easily. So, light, heavy in this case, in our case are primary terms, and then we have found the slightly heavy, extremely heavy, heavy but not too heavy, slightly light, extremely light, light but not too light, not light and not heavy. So, like that we can find any suitable composite linguistic terms by using the primary terms, hedges and connectives, and this way we can manage to get lot many composite linguistic terms, and that understand as to how we get all these composite linguistic terms using the primary linguistic terms, hedges and connectives. So, with this I would like to stop here, and in the next lecture we will study the contrast, intensification and orthogonality of fuzzy sets. Thank you.